In this video, we're going to finish with the topic of polynomials by looking at the intersection of two graphs. Now we know that given two equations of graphs, we can find their points of intersection. And we've already got experience of this with straight lines in National 5 and quadratics and straight lines in the previous topic of quadratics in higher. So that wasn't too long ago. Now, two graphs could have several points of intersection. So you can see this one here is a quartic and a straight line, and it's got 4 points of intersection. It may only have 1 point of intersection, where it's a tangent, or it may have no points of intersection. So we'll explore some of these in the example that we're going to do. So we want to find the coordinates of the points where the curve with equation y equals x cubed minus x squared intersects the line with equation y equals 5x plus 3. So we can see firstly that both of the equations we have been given are y equals. So that means that these are both equal to each other. We can equate them. X cubed minus x squared is equal to 5x plus 3 because they were both originally y equals. So subtracting our 5x and our 3 from both sides gives us x cubed minus x squared minus 5x minus 3 equals 0. And then we need to try and find a root of this equation, this cubic that we've got. So let's start with x being equal to 1. So when we substitute that in here, 1 cubed minus 1 squared minus 5 times 1 minus 3, that gives us negative 8. If we try x equals negative 1, so negative 1 all cubed minus negative 1 all squared minus 5 times negative 1 minus 3, that gives us 0. So that means that x equals negative 1 is a root of the equation here, x cubed minus x squared minus 5x minus 3 equals 0. And that also implies then that x plus 1 is a factor of this expression on the left hand side. So we can continue this equation solving here by saying, well, x plus 1 multiplied by something will give me 0. So we need to find out what that something is, and to do that we employ the grid method. So we've got our x plus 1 down the side, and we can already put into our grid the x cubed, that's the term with the highest power of x, and our negative 3, our constant term. And working our way through the grid, so x multiplied by what gives us x cubed, and that's x squared. Positive 1 multiplied by x squared gives us positive x squared, but we're looking for negative x squared. So we need to subtract 2x squared. Then x multiplied by what gives us negative 2x squared, and that's negative 2x. And then we can say to ourselves 1 times positive 1 multiplied by negative 2x gives us negative 2x, but we are looking for negative 5x. So we need to subtract another 3x. X multiplied by what gives us negative 3x, and that's negative 3. And then we do a wee quick check. 1 multiplied by negative 3 gives us negative 3. So we have factorised correctly, and our quotient there is x cubed minus 2x minus 3. Now, when we factorise this quadratic then, we're going to get x minus 3, x plus 1. So you can see that the cubic fully factorised is x plus 1, x minus 3, x plus 1 equals 0, and hopefully you've noticed here that we've got a repeated root. So we've got x plus 1 all squared multiplied by x minus 3 equals 0. Now, using the null factors theorem, we can make each of those brackets equal to 0 and solve them. So the first bracket will give us x equals negative 1, and the second bracket x equals 3. Now, we are asked for coordinates of the points where the curve and the line intersect. We currently only have x ordinates, so in order to find our y ordinates, we need to substitute in. And we're substituting into one of the original equations, So I've chosen the straight line just because it's possibly slightly easier than substituting into the equation with the cubes and the squares. So when x is equal to -1, y is equal to 5 times -1 plus 3, and that gives us -2. When x is equal to -3, 5 threes plus 3 gives me 18. So my y ordinates are -2 and 18, and that gives me the coordinates of -1, -2 and 3, 18. And if we look at the graph here, the curve obviously is in red there, and the straight line is in blue, and you can see both of those points of intersection there, -1, -2 and 3, 18.